Hey guys, welcome back to my channel. In today's video, we are going to see how bubble sort is working, and then we are going to implement it using C++. Okay, so see, before getting into the algorithm, how bubble sorting, this algorithm works. First of all, let's look into the key concept. Like, what is the key concept? What is the key concept behind bubble sorting? It's basically comparing two adjacent values and then making them in order, right? So let's see, like I'm comparing these two values. Are they sorted? 9 and 2? No, right? So I should basically make them in order. So after making them in order, this will be 2 and 9, right? So that's how we are going to do this bubble sorting, right? So for example, last video we have seen selection sort, right? Selection sort. So what we did, the selection, this word, we know that selection, we are selecting something. So what we did, we selected the minimum element, like among this whole array, we selected the minimum element and kept at the beginning. And for the second index, again we selected the minimum element, right? So here we are not selecting anything. Here we are bubbling. Basically we are bubbling between two indices, between two adjacent indices, and basically we are making them in order, right? So how the actual algorithm goes is like, see, first of all, I'm going to compare these two adjacent elements. Are they in order? You will say no, they are not in order. So make them in order now. So after making them in order, 2 will be here, 9 will come here, and then rest of the elements as it is, 5, 10, 0, 1, right? And in the next step, what I'm going to do, I'm going to move this pointer one step forward. Like this pointer will be here, and this will be checked with the adjacent element, basically the next element, right? So 9 and 5, are they in order? I'm saying no. Why? Because 5 is lesser than 9. So 5 should be before 9. Okay, so let's swap it. Let's swap it. So 2 will be here, 5 will come here, 9 will come here, rest of the elements as it is, right? And for the next step, in the next step, what happens? This pointer will come here, right? So 9 and 10, are they in order? Yes, they are in order. Why? Because 9 is lesser than 10, right? So let's write this thing as it is, no change. Sorry. Okay, let's write once again 1, 5, 9, 10, 0, 1, right? And now move to the next index, right? Next is 10. 10 is being compared with the next element. So 10 is lesser than 0. Is it right? No. 10 is basically, it's the greater one. So 10 should be after 0, right? So we are just going to swap them basically. So after that, 2, 5, 9, 0, 10, 1 will be coming, right? So now let's move the pointers again. The pointer is now here. 10 is lesser than 1, but that's not the case. So we should swap it. We should make them in the correct order, right? So after swapping, it will be 2, 5, 9, 0, 10. Sorry, 10 won't come here. Let me just erase it. Where is this eraser? Okay, I got this. Okay, so here 1 will come and 10 will come here, right? Then this iterator will be pointing here. But do I have next element? I don't have. So is it possible to compare? No, it's not possible to compare. So basically what we did, we basically went from 0th index till n minus 2th index, right? N minus 2th index, and we are just checking whether they are in the correct order or not. If they are not, we are making them in the correct order by swapping those elements, right? So see, can you notice something? Can you just notice something here? This is one step. I mean, in first step, or let's say 0th step, we will be iterating, right? So in the 0th iteration, this will be happening in the first iteration. So basically, let's say like, let's say for loop is running from I equal to 0 till some number, right? So when I equal to 0, I'm just calling it as a 0th iteration, right? So on the 0th iteration, this is what is happening. So see, what is happening here? What is 10? What is 10? 10 is the maximum element. 10 is the maximum element in this array, right? So the maximum element will be pushed to the backside. In each step, the maximum element will be pushed to the backside of that, right? So in first step, 10 got pushed to the backside. Can I say till here the array is sorted? I mean till here, like right hand side, right? 10 is there, okay? You will be saying, okay, there is only one element. So how can I judge something like that? The right hand side is sorted. Okay, let's see. Let's go for next step. So now the elements are 2. Okay, let's zoom a bit. Okay, 2, 5, 9, 0, 1, and 10. Now let's do the same thing again. A pointer will be going from here till here, right? So let's see. 2 and 5 is being compared. Are they in the correct order? Yes, they are in the correct order. So write as it is. This pointer got incremented. And now 5 and 9, are they in the correct order? Yes, that they are in the correct order, right? Now let's write the same thing as it is. We are not swapping anything. Till now we didn't swap anything, right? Now this pointer got incremented and this is here now. 9 and 0, are they in correct order? I am saying they are not. Why? Because 0 is lesser than 9. 0 should come before 9, right? So I am just swapping it. So after swapping, this will become 0 and 9, and write rest of the elements as it is. So now this pointer got incremented and the pointer is here now. 9 and 1, are they in the correct order? No, because see, 9 should be after 1, right? So let's swap it. 1 will come here, 9 will come here, 2, 5, 0, and 10. Rest of the elements as it is, right? Now the pointer again it got incremented and the pointer is here. And now it's checking for 9 and 10. Remember what I said? What did I say before? Till here it's already sorted. After this boundary, it's already sorted in the right hand side, right? So do I really have to check for these two? But what I am saying, this boundary will keep on increasing. See, right now the boundary is here. I know it might be slightly confusing. Let me just give you a broader perspective, like what we are doing. What we are doing is basically, see, in the first step, what we did, we actually pushed the greater element, the maximum element, to the end. Like this 10 will come here, right? In the second step, we are actually pushing this 9 here. What we are doing, except this 10, we are pushing the maximum element again at the end. So 9 will be here. And in the third step, so after 9, 5 will come, right? Similarly, 5 will come here. And in the fourth step, this place also will be filled. In the fifth step, this place will be filled. And what I'm saying, it's not necessary that you have to do this whole steps, right? Let's say hypothetically, let's say the array is already sorted. 0, 1, 2, 5, 9, 10. It's like already sorted. We don't have to go for this. But what I'm saying, at the worst case, you have to do these many operations. They'll be like, how many operations? I mean, these many operations in the sense. See, first I'm putting the greatest element here. In the second step, I am putting the greatest element here. In the third step, I am putting the correct element here, then here, then here. So do I have to put here? No. Why? Because see, if the entire array here is already sorted and they are the greatest numbers, this number will be the smallest, right? And this number will be already sorted with this array. So we have to do this operation how many times? Let's say the elements are 1, 2, 3, 4, 5, 6. There are 6 elements. We had to do in one step, in second step, third step, fourth step, 5 step, right? We took 5 steps. So we'll be going for n minus 1 steps. We will be doing this n minus 1 times. In one step, what I'm going to do, I'm going to simply keep a pointer and I'm going to simply compare it with the adjacent element and go forward, right? Move forward. Moving forward, making sure that they are in the correct order. And once a pointer moves from here till here, this entire thing is called a single step, right? So that's what we did here, right? See, step 1, we moved a pointer from here till the last index and we got the last index value. Step 1, right? So we did the same thing again and we got the value here. Second step is nothing but the same step, the same thing again we did once more, right? We are doing the same thing again and we got the value for this index. We are doing the same thing again, right? Basically, we will move pointer from the starting index till the last index n minus 1 times because we will be placing the elements in their correct order n minus 1 times. Basically, we will be placing here, 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 except the last index. You can also place this one. You can run this loop for n times also, but I don't need that, right? So that's the reason I'm going for n minus 1 time, right? And now let's observe one thing. So the first thing, the outer loop. Outer loop basically will run n minus 1 time, right? Inner loop, what is happening? Inner loop, a pointer is getting initialized at the starting index and it's going till this point, right? And we got the value for this. Basically for the next step, again this will happen. So this pointer will be starting from here and it will go only till here. You'll be asking why only till here? If pointer is going only till here, it's basically comparing this and this, right? And I'm not comparing this value because see, this is already sorted, right? That's the reason we are not comparing with these elements. These elements we are not comparing because we know that this part is already sorted. Similarly, for the next iteration, let's say 10 is here, and let's say for the second iteration after doing this second step, 9 came here. And for the third step, this pointer will start from here itself, as always. But it will go till, not here, it will go till here because when I go till here, this is actually comparing with the next element, right? So these two elements will be compared at the end. Why? Because we know that this array is already sorted, right? So as the outer loop increases, the inner loop ending point is decreasing, right? See, let's say I'm running a loop from 0 to n minus 1 in the outer loop. I'm calling this as, like, let's say 0th step. 0th step is basically from here I will go till here and I got this answer. So in zeroth step, the iteration will be from 0 till n minus 1. Pointer is lesser than n minus 1. Now in first step, that means after one step, after zeroth step, here comes the first step. In first step, it will go from 0 till p is lesser than n minus 1 minus 1. Right? Why minus 1 minus 1? Because see, I'm decreasing this pointer range by 1. Because I already have 10 here. So I will only compare this and this. And I will be having 9 here now. So this sub-array is already sorted. Let's move forward. For the second step, this pointer will be moving from 0 till p is lesser than n minus 1, minus 1, minus 1, one more minus 1. Let me just simplify this and write p is lesser than n minus 2, and here p will be lesser than n minus 3, right? So similarly, for the third step, p will go from 0 till n minus 4. So now what's happening? This is the outer loop, right? And this is the inner loop. Of course, we are doing that operation. We will look into that operation, like swapping, not swapping and all. But right now, I'm talking about the iteration, right? So on the zero step, from 0 to n minus 1, sorry, lesser than n minus 1, that is still here. First step, 0 to lesser than n minus 2. The second step, 0 to less than n minus 3. So can I write in a generalized formula? If let's say the outer loop is I, like let's say ith step, and let's call this P as J. Let's say this is the inner loop. So J will be from 0 to J is lesser than n minus 1 minus I. Can I say this? Of course I can. Why? See, on the zero step, P is lesser than, let's say J is lesser than n minus 1 minus 0. Right. Here, minus 1 came. So it became minus 2. Right. N minus 1 minus 1 minus 2. Here, n minus 1, this minus 2. So this became n minus 3. For the third, again one more. For the third, it becomes something like n minus 1 minus this value 3. So this will be n minus 4. So that's the point. Inner loop runs from 0 till n minus 1 minus I. I mean j is lesser than this. Now let's write the pseudocode, right? So let's say I'm going for an outer loop. Let's say int I is from 0 till I is lesser than n minus 1. So this loop runs for n minus 1 times, and the inner loop will go like int j from 0 till j is lesser than n minus 1 minus I times. And then inside this, I'm just checking whether ARR of j is greater than ARR of j plus 1 or not. If it is, that means they are not in order. So I will just swap it. J ARR of j plus 1. And I'm going to close this if condition, close this for loop, and I'm going to close this for loop also. So let's write the code. So this is the input, and here we are going to print the output, right? So here we are going to write the bubble sort, right? So outer loop will go from I equals to 0, I is lesser than n minus 1, I plus plus, which basically means that this will go for I minus 1 times, and in each time what we are going to do, we are going to compare, right? So the comparison loop will be int j equals to 0, j is lesser than n minus 1 minus I, j plus plus. Why minus I? Because on each step we are reducing the number of comparison by 1, because the last indices are already sorted, right? So here I am going to check whether AR of j is actually greater than AR of j plus 1 or not. If they are, that means we have to swap them. So swap AR of j and AR of j plus 1. That's it for the algorithm, and if you run this, yeah, it's getting the output 23489, right? So that's it for the video. If you like the video, please hit the like button, subscribe to our channel. Until next time, see ya.